So this is a session about Math 1127, session 7.5. And 7.5 is the goodness of fit test, or some people call it the chi-square test. Chi-square test is basically, on your calculator, look like this. Stat test, can you see this right here? This one. Now here's the problem. Our calculator is not going to work very well with this homework section. And the reason is your calculator is doing what you would do in real life. And ironically, in our homework, they give you information to make it a little bit easier. But because it's easier, the calculator doesn't work in this sense. So it's probably easier if you just use the formula that we're going to have. And it's going to make it a lot easier if I do it. So now, for the goodness of fit test, what is this thing? What's chi-square test? Chi-square test is basically a test for a hypothesis test for the standard deviation. Right. And of course, if you use, and you guys remember, standard deviation is simply the variance. Standard deviation square is the variance. So basically, if you're testing for the standard deviation, you're also testing for the variance. It's the same thing. One is the square of the other. Now, how do we set it up? So in this case, here's what we got. We have two hypotheses. Right. Now we're testing for the standard deviation, right? So let me go ahead and use this. It's probably easy. For every chi-square test, we'll have a null hypothesis, which is this guy. And it's going to be not the mean or not the proportion this time. It's going to be the, what's the symbol? It's going to be this guy right here. That's the standard deviation of the population, right? So either this, I'm just making an example, maybe bigger, right? Bigger than or equal to, let's just say 100. And then the other guy will be, let's see. Let's just say the alternative is going to be less than 100. Right. So it could be, could be the second one is a claim, maybe not, right? So instead of talking about the mean being bigger than or less than 100, or the proportion being bigger than or less than, now we talk about the variance or the standard deviation. And the problems are going to be very similar to that. So let me show you this. Before, when you have the hypothesis test, we use the t-test and the z-test, and they all look kind of like this. Before, they look like this. Like this, right? That's the t-test and z-test. I know my joint's not very good. But it turns out right now, it's almost the same thing. Our test is going to look more like this. It's going to look more like this. Like that. So, doesn't matter. The only difference is, because all we care about is where's the rejection zone. So you can still have your left tail test like this, or your right tail test like this. Or you may have a two tail test, right? One on the left, one on the right. Same thing as before. If you have an alpha, right, it's gonna be like say 0.5 will be on the right, right, or on the left. If you have a two tail, you can have it divided by 2. It's exactly the same thing as before. Now, let me just do a problem so we know what's up. So here's the first problem. So this is problem number 6. We have, so let me clear this out as well. Actually, I don't have to clear it. I'm just gonna use this. So here's the thing. They say use the chi-square test to test whether or not to claim that the standard deviation is bigger than 36. So right from the start, I'll go ahead and change that to bigger than equal to 36. And this is the claim this time around. So the bottom, of course, will be less than 36, right? Just like what we did before. Now, we are going to use the level significant. Alpha is going to be 0.1. And before we dive into the other stuff, let me just kind of get the kind of like a picture of this thing. So if alpha is 0.1, and this is going to be a chi-square test, and it's going to be a one tail, a left tail, a left tail test because it's less than, right, or the alternative. It's going to be a left tail test. So you can look at a picture like this. I wonder if I can draw here. Draw. No, I guess not. So yeah, I'm not very good at drawing these guys. So I'm just drawing the paint. So basically, here's what's gonna happen. We are gonna have this guy, and let me draw this. It's gonna be like this, right? And we are gonna have a left tail test. So left tail means we're gonna have this right there. It's a left tail test. So now here's the thing. We know the alpha is 0.1, so we're going to do alpha equal 0.10 like that. So now let's look at the formula. Like you can actually go into the homework and click on this right here. They should give you the page. So that maybe make it a little bit easier. I don't know. So here's the deal. Look at that. When you look at this thing, the numbers that you see on this table, by default, it's the right tail. Now we have a left tail. So if it's right tail, you go right ahead and look at 0.1, no problem, and that's the answer. But we are looking for the left tail. What does that mean? If the left, so think about it, right? If the left tail is 0.1, don't you think the right hand side, the left hand side is 0.1, right? So the left over will be 0.95, right? That's what we're looking for. To find the critical value down at the bottom, you have to find 0.95, which is right here, this column right here. And we have to match that to the corresponding degree of freedom, which is your sample size minus 1. Now the sample size is 12, right? N equals 12. So minus 1 is 11, which is right here. 11, 0.95, 11 is 4.575. So let me go ahead and type it in. The critical value is 4.575. So that's the critical value. So let me go to the paint and just type it in. 4.575. So basically, whatever results we get from the information we're going to get later, it would either fall to the left or the right of this thing, right? And remember, just like before, the left-hand side represents the rejection zone. So this guy right here is the rejection zone. So if your statistic, your test statistic, falls on the left to this line, you will reject the null hypothesis. On the right, you will fail to reject. So now let's see what's going to happen with this guy. So understand that for us, we have to use this formula. So if you go back to the formula sheets I sent you, this is the formula right here. Chi-square test. It's probably easier just to use this than to do anything else. I know your calculator have some shortcuts. I know some of you guys can go on Google and find those calculators. This is probably the best way to do it. So what are we supposed to do here? We are supposed to use this use the chi-square test formula. And let me go ahead and insert the equation here, just so that we have it. C equals, gonna be a fraction. It's gonna be n minus 1, right? The sample size minus 1, multiply. Let me try to use the dot right here. Let's dot it right. Dot s square, and then the bottom is gonna be the standard deviation for the population square. So that's the formula. I just used that. So let me see, and I'm gonna upload this guy. So maybe I should say it right here. This is Mat 1127 session 7.5, and this is the kind of like the first example. So this is example. Let me see, 7.5.14. All right. So now let's go back down here. So what do we know? Based on this problem, we know that the sample standard deviation, right, so the sample statistics that are given to us, S equals 34.2. That's a sample standard deviation. N equals 12. That's a sample size. All you gotta do, man, is plug it in. So we have, so I'm gonna copy this right here. So basically we have 12 minus 1. The standard deviation is 34.2. The population standard deviation is 36. And just put this on the calculator. So let's say that's when the calculator becomes handy. So all you gotta do is put in 12 minus 1, which is 11 here. 34.2 squared, and then divided by 36 squared. Enter. And I got equals 9.9275. So look at this. Oh, so look at this. So this is the test statistic is 9.9275, and I forgot how many decimal places they want. But so what does that mean? Let's go to the paint. Meaning right now the stuff we got, and I'll make it blue. It's gonna be on the right hand side right here. So it's gonna be 9.9275. 9.9275. So of course it's firmly in the safe zone, right? This is a safe zone. Right. So like fail to reject the null hypothesis. So that should be the result. But let me go ahead and answer some of the questions on there. So first, what do we know? Based on this thing, it tells us that let me make this a bit bigger. So, so looking at this guy. So first, identify the null and alternative. Well, we did that already. So bigger than or equal to 36 and less than. So that's pretty easy. What is the test statistic? 9 points. So we don't want 3 decimal places, right? So let me just change that to 9.928. There you go. And what's the critical value? you only have one critical value because it's left tail. It's not two tail. So the critical value is 4.575. Let me see. Let me look at this just to make sure. So the degree of freedom is 11 and 0.9. Oh. It should be 0.9. My bad. I don't know why I don't 0.95. So that should be 5.578. 5.578. Right. So there you go. 5.578. And then change your own paint as well. So that should be, let me erase this. There will be 5.578. There you go. And that should, yeah, I don't know, something wrong with me. That should be 0.90, right? I don't know why I thought it was 0.95. 0.90. There you go. So let's look at the problem. Since we're in a safe zone, we will fail to reject the null hypothesis. If we fail to reject, look at the claim, right? The claim is the null hypothesis. So the conclusion would be there is not enough evidence to reject the claim. So that should be it. D. There you go. The result is the same, regardless. Now, let's look at number 8. Number 7 is the same thing. Right? If you look at number 7, we have 0.025 significance level, right? Random samples 28. It's just a wordy problem, but they still have the standard deviation. This guy right here is 0.065. Basically, the question is whether or not it would be, let me say, to test whether or not it will be less than that. So you should have a bigger than or equal to, then a less than, and that should be the claim, right? It should be D. But then everything else is the same, like the critical values and all that. The critical value. So find the critical value, that's 0.225, right? So again, you look at the table, which is, I actually have it right here. So the table would be, the chi-square table is all the way at the bottom. I'm going to rotate the view first. Like this. And it's kind of hard to read this, but let me make it bigger. So like this. So this again on your formula sheets, right? My suggestion is just print it out and use that. So now let's say the significant level is 0.025, and this is a left tail, just like the last problem. So you have to subtract that from 1. So 1 minus 0.025. I have 0.975, right? So let's say 0.9. Oh, you know what? They don't even have it here. So what I'm gonna do is use the there was a calculator I was using, chi-square critical value calculator. That's probably the easiest way. And just use let me see. I like this one better. So the degree of freedom is, let's say, 28 is the sample size. Subtract 1 is 27. So that's 27 degree of freedom. What's the probability level? It's 0.975, right? So 0.975. Calculate that. And there you go. The critical value is 14.573. So I'll send you guys to the website as well. So 14.975. Or 573. 573. Like that. And that is 3 decimal places. Alright, got it. Very nice. Now let's go down to So the rejection zone, right? So it's a left tail test. So it should look like this one, just like the last problem. Gonna hit the continue button to go to the next one. So then now use a z, the chi-square test to find the actual test statistic based on these information here. And remember, on the calculator, just gotta use the formula. This formula right here, right? The a minus 1 thing. So let's try that again. So 28 minus 1 times, what's the sample standard deviation? The sample has a standard deviation 0.041. Square that, then divided by the bottom should be 0.065. That's a population. Square that. So they want you to round to 3 decimal places. So that's 10.742. There you go. And because 10.742 compared to this guy, right? 10.742 will be on the left of 14. So it will be on the left of this line. So there will be rejection zone. So you'll reject the null hypothesis. And the null hypothesis is not the claim. The claim is the opposite, is the alternative. So therefore, since the null hypothesis is rejected, then well, the new equipment is being tested in an attempt to improve quality. So the question is the new equipment better off? Is the standard deviation lower? That's a question, right? So is it less than? Well, since the null hypothesis has been disproved, the null hypothesis is bigger than or equal to. That has been disproved, right? So therefore, we are less than. If we are less than, then that's a good thing. Come, according to this problem, you want to reduce the variation. So therefore, since the null hypothesis is rejected, the new equipment appears to be more effective. I know the word problems are a bit crazy. The math is the same. Now let's look at this one. So this problem is gonna be. Let me just copy some of these right here. So the new problem is example 7.5.23. So in this case, we have a whole lot of numbers that we gotta type in. But that's all right. We'll type it into the calculator. So first, let's look at the problem. It says the alpha is 0.05. That's the level of significance. And what are the claim? Let me say. They say that the standard deviation of the salary is different. That's the claim. So either it's different or not. In our case, right, you have two choices. It's either equals, right, equals to 5450. That's the standard deviation, right? It's either equal to this, and this is not the claim, or not equal. It's not equal. What's the not equal? Right. So not equal to 5450. And this is the claim. Right. They say it's different. Right. So all of this is now a two-tailed test. Two-tailed test. And let's see what a critical value is going to be. Now, the critical values, you're going to have two this time around. So why do we have two? Because you have two tail, one on the left, one on the right. So the critical values are, we can look at the table here. Right. Again, this is on your formula sheet, or you can use the other. You can use the calculator that we had before. Alpha is 0.05. So here's the problem. If alpha is 0.05, you have to divide by 2 because it's a two-tail test. So you have to look at 0.025 and 0.975. Those are the two ends. So just to draw the picture, basically this is what we got. You should have you should have you should have a zone on the left, like right here, and one on the right, just like that, because it's two tail. And what you got is in here should be 0.025, right? Because the alpha, that's right, the alpha equals 0.05, right? So half of that is on the left, then half of that is on the right, right? So this is 0.025, this is 0.025. So now here's a game you gotta play. Over here, over here is the, you can think about, this is the, let me draw a picture. From here to here. From here to here. Right. You have 1 minus, like 100%, right? 1 minus 0.025, which is equal to 0.975. That's how much of the probability is from here all the way to the end, right? So let me see. Similarly, let me draw the picture from here to all the way to the end, to over here, right? This would also be 0.975. So looking at the table, remember the table gives you what's on the right. Right, that's very different. In the past, it's always on the left, right? Now it's on the right. So you just gotta kind of wise up a little bit, right? Just gotta look at 0.025. That's the one on the right. So 0.025. What's the degree of freedom? So the sample size is 14. The degree of freedom should be 13. So 13, 0.025. That should be 24.736. So that should be 24.736 on the right. Now, what's on the left? On the left, you have to use 0.0975. So let's go to 0.0975, and degree of freedom is what again? 13. 5.009. So there will be 5.0. What was it again? 5.009. Like that. So basically, everything on the left of this line is rejection. Everything on the right of this line is also rejection zone, right? So let me go ahead and answer that question. So first, just want to make sure this is correct before I move on. So the first thing I would do is critical values are 5.009 and 24.736. Right. So let me go ahead and answer some of those questions first, just to make sure it's correct. So what do we know? This is the, right, so this is the test. equal or not equal. So that's the first one. And then one of the critical values is going to be 5.009, comma 24736. Oh, I don't know why I didn't put a decimal in there. There you go. Now, it's going to look like the rejection zone. It's not going to look like that. It's going to be on the left hand side and the right hand side, right? So yeah, these two look very similar, but you see how like this one got two? Like you can click on this right. Two, it has two N, right? That's the one we want. So now let's see, what's a test statistic? This is the one that's a little bit intimidating because they're giving you these numbers here, right? So here's what you gotta do. I will go to the calculator, right? I will go to stat, add it. I will put those numbers here. As you can see, I already have some numbers in there from the last problem. Let me just go ahead and enter and clear it. So you want to put all those numbers you see on the left into the calculator, into L1 or L2, whatever you want. So I'll do 507714. Enter. All right. So let's go ahead and put everything in there. You can also do this on Excel if that will make it a little bit easier for you. Since you can do basically what we're looking for is to find a standard deviation. But I think most of you guys are using calculator anyway, so this might be better. All right. So here's what I would do. I'll go out, right? Hit stat, go right. You see one variable stat. That's what we want. And I just usually hit second one just to get L1. If you have, by default, it's gonna be L1. But I do it just to be a little bit more careful. So you see, I got all the information now. The mean, the standard deviation, the N is 15. Right, we got, hold on, 15. Wait a minute, something is wrong. Because we should have 14. Right? So let me just double check. It's good to look at it before you do it. So before you get the numbers, let me say what I'm guessing. I might have some duplicate up in there. Let me say. Okay, 15. Oh, here, I got it. You see how I have a duplicate in there? So let me just hit the delete button. So there you go. So now let's see. Let me try this again. And I got, look at this. So this says that I have, I don't know what's going on here. So based on what it says is that, let me just delete everything in there first. So the sample statistic in our case, now use this one here. The sample standard deviation, which is 7783.99. Use that one. And what is so don't use the population one. Don't use the sigma one, right? Use the S. And what's the N equals? The N is 14, right? So now let's plug this into the formula. So that will be 14 minus 1. The sample standard deviation is 7783.99. And the population standard deviation claimed by the people is 5450. So that's what you're going to put into a calculator. So let's say that will be parenthesis 14 minus 1, right? Close parenthesis, times 7783.99 square, then divided by 5450 square. And I have 26.52. Now, this guy is on the right hand side of 24. Right, this guy's on the right hand side of your right limit to your picture. So it's like it's gonna be the test statistic in this case. It's gonna be right here, like right here, which is 26.52, right? So it's in the rejection zone. So you should say this, right? This is gonna be, since the test statistics is in the rejection zone, then we should reject the null hypothesis. And since, if you scroll up a little bit, we should reject this guy right here. So reject this, that means the claim is supported by evidence. So we have enough evidence to support the claim. There you go. So now looking at this and see if we can answer the questions. So the test statistic is 26.52. Done. And then we reject the null hypothesis. And therefore, because the test statistic is in the rejection region, I call it zone, but they call it region, the same thing. So since the null hypothesis is rejected, there is enough evidence to support the claim. There you go. So it's always good to just get this done first on the right-hand side. All right. Now, this is the same thing. So give it a try. But this one's easy. This one's the one that's, I think this one's the harder one. So anyway, give it a try. And if you have any questions, just let me know.